wave in any medium, then simply you have to replace this permeability of a free space by the permeability of that medium, and permittivity of a free space that you have to replace by permittivity of that particular medium. Clear? Then another relationship is also very important, that is C equal to E0 upon B0, or simply you can take E by B and you can take E RMS. RMS means root means square value. So E RMS upon B RMS also. Clear? Now, if electromagnetic wave incident on any surface, after all, electromagnetic wave, that is nothing but energy. So on any surface, if electromagnetic wave incident, okay. Now, suppose we consider like this entire energy incidenting on the surface is absorbed, means reflection is zero. Okay, so in that particular case, we can say the momentum is imparted on the surface, and that momentum imparted on the surface is given by U upon C, where U, that is the total energy incidenting on that particular surface. Okay. Now, if momentum is exerted on the surface, it implies that now we can say this thing: when electromagnetic waves incident on any surface, it exerts some pressure on the surface, and that particular pressure exerted, that is called radiation pressure. That is called radiation pressure. Then after, intensity of wave. Now, intensity of wave means what? The amount of energy passing through unit area per unit time perpendicular to the surface is called intensity of wave. Now, to understand this concept of intensity and to write its equation, let's consider this figure. Suppose, as shown in the figure, we take any plane surface having area equal to A. Now, suppose energy passing through this particular area perpendicular to it in total time T is E. Now, as per definition, energy passing through unit area or energy incident per unit area per unit time perpendicular to it, that is called intensity. So here we can write now equation of intensity, that is total energy passing through the surface or incidenting on the surface, that is E, divide it by total area. So we will get energy per unit area. Again, divide by T, means energy per unit area per unit time. We will get this thing. Now, energy upon time, that is called power. So we can write the equation of intensity, that is E upon A into T, or we can write intensity, that is power upon area. Unit will be watt per meter square. Now, say this energy passing through this particular surface, that energy cover how much distance in time T, means that energy is in the form of electromagnetic waves. It implies that here the electromagnetic waves which are passing through this particular surface will cover how much distance in time T. So electromagnetic waves are moving with speed equal to C. So distance covered by these waves, that will be equal to C into T. So in other words, we can say the energy which one is passing through this area A in time T, that will be accommodated in the space equal to distance D. Clear? એટલે અહીંથી અહીં સુધી ની જે સ્પેસ છે એમાં એ એનર્જી એકોમોડેટ થશે. Now, suppose E upon AT, this equation is multiplied and divided by D, the distance covered by these electromagnetic waves in time t. Then A into D, that will be this volume in which the energy is accommodated. So E by V into D by T we can write, but E by V, that is energy per unit volume, and that is called energy density. And D by T, that is the speed of light or speed of electromagnetic wave. So we can write rho into C, rho, that is energy density. Means we can write the equation of intensity as E upon AT, or we can write intensity equal to power upon area, or we can write intensity that is equal to energy density into speed of electromagnetic wave. Clear to all of you? When electromagnetic wave itself is energy, it implies that if in the space electromagnetic waves are present, then at any point, okay, the energy density, that is in the form of electric field as well as magnetic field. Now, in previous chapters, in chapter number 2 and 4, we already derived equation of energy density at any point in the given space. Okay, and in the form of electric field, the energy density is given by rho E, which is equal to half epsilon 0 E square, and in the form of magnetic field we represent energy density, that is rho B, and that is given by half B square upon mu 0. Now in case of electromagnetic waves, the energy that is present in the form of electric as well as magnetic field. So we can write the energy density at any point in the space in the presence of electromagnetic waves, that is rho E plus rho B. Now rho, that is rho E, that is half epsilon 0 E square, and rho B, that is half B square upon mu 0. But we already discussed E by B, that is C. So from this one we can write E equal to BC, or we can write B equal to E by C. As well as we discussed C, that is equal to 1 upon under root mu 0 epsilon 0. Therefore, C square equal to 1 upon mu 0 epsilon 0. Okay. Now, we can derive the equation of energy density exclusively in terms of electric field as well as magnetic field. Okay. Now, say, suppose first here we substitute E equal to BC. So our equation will be rho equal to half epsilon 0 B square C square plus half B square upon mu 0. But now replace C square by 1 upon mu 0 epsilon 0. So in this first term, epsilon 0 will be cancelled. So you will get half B square upon mu 0 plus half B square upon mu 0. So resultantly you will get energy density, that is B square upon mu 0. Then after, in this equation, take B equal to E by C. So half epsilon 0 E square plus half 1 upon mu 0 E square upon C square. So half epsilon 0 E square plus half 1 upon mu 0 E square, and this now 1 upon C square is replaced by mu 0 epsilon 0. So this mu 0 cancelled. So we can write this is equal to half epsilon 0 E square plus half epsilon 0 E square. So you will get rho equal to epsilon 0 E square. So these are the equations of energy density at any point in the space in presence of electromagnetic waves in terms of electric field as well as magnetic field. Clear to all of you? Any doubt in this one? Say, then after the topic that is electromagnetic spectrum. So Maxwell suggested electromagnetic wave theory, and then Hertz gave experimental evidences for the presence of electromagnetic waves in nature. Then after so many scientists worked in that particular direction, and at present we know this thing, the electromagnetic waves having wavelength from 10 raised to minus 14 meter to 10 raised to 7 meter exist in the nature. એટલે આ જે બધી જ વેવલેન્થ્સ ના ઇલેક્ટ્રોમેગ્નેટિક વેવ્સ નેચરમાં જે પ્રેઝન્ટ છે, રાઈટ, એના depending on the wavelength or frequencies and characteristics, this entire electromagnetic spectrum is divided in different parts. Okay, and now just you have to go through this particular electromagnetic spectrum. Out of this entire electromagnetic spectrum, our eyes are sensible only for very small part of that region, which is called visible region, and the wavelength of visible region, that is 400 nanometer to 700 nanometer. And see here, the different parts of electromagnetic spectrum are gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, short radio waves, television and FM radio waves, AM radio waves, long radio waves, like this. And here there is no demarcation line for any part of this particular electromagnetic spectrum. એટલે કે એક્ઝેક્ટલી આ વેવલેન્થ આ પાર્ટ પૂરો થાય ને પછી એના પછીની વેવલેન્થ થી બીજો પાર્ટ સ્ટાર્ટ થાય એવી કોઈ ડિમાર્કેશન લાઈન આમાં છે નહીં. અને આ બધા જે ડિફરન્ટ પાર્ટ અહીંયા બનાવ્યા છે આપણે, that depends on frequencies and the characteristics of electromagnetic waves. અને એ બધું જસ્ટ આપણે રીડ આઉટ જ કરવાનું છે અને પછી યાદ રાખવું પડશે. Now see the table number 8.1. તો 8.1 માં તમને આખો જે ઇલેક્ટ્રોમેગ્નેટિક સ્પેક્ટ્રમ છે એના ડિફરન્ટ પાર્ટ્સ જે છે એના નામ, પછી એની વેવલેન્થ, રેન્જ, then production, how it is produced, and then detection, આ બધું તમને આપેલું છે. તો એ યાદ રાખો એટલે તમને મોટા ભાગનું મેમરાઇઝ થઈ જાય. પછી તમને આ ડિફરન્ટ જે ઇલેક્ટ્રોમેગ્નેટિક વેવ્સ છે એના ડિફરન્ટ યુઝીસ પણ તમને આપેલા છે, બરોબર છે. તો આ 7 પાર્ટ જે આપણને આપ્યા છે એની વેવલેન્થ ઓર ફ્રીક્વન્સી રેન્જ, પછી એના યુઝીસ, ઓકે, પછી એનું પ્રોડક્શન કેવી રીતે થાય છે એ બધું જ આપણે યાદ રાખવું પડશે. They can ask you as a short note also. Clear? So that you have to read just.